Well, hello. Glad to have you back here for tonight. It's our last chance to get ready for our common assessment tomorrow, and we probably ought to get started. Today we're going to be talking about projectile motion. We're going to be reviewing uh, free body diagrams, and we're going to be talking about vector components and projectile motion. All right, our first problem here in projectile motion says a tank shoots a blank projectile 200 meters per second at an angle of 35 degrees from the horizon. Find the x and y components. Well, to start off here with this, um, if I get my, there we go. We've got this and it's shooting it off at 200 meters per second at an angle of 35 degrees from the horizon. So what we've got to find now is our x and y components. Well, we just got done doing some um, force where we had something on an incline, and we took mg sine of theta to find the opposite. We took mg cosine of theta to find the adjacent. Well, it's not mg in this case, but it is still the hypotenuse. So if I want to find the opposite, it's going to be 200 times opposite on hypotenuse is sine, so that's sine of 35 degrees. And if I want to find the adjacent, right, it's going to be 200 cosine of 35 degrees. And hopefully that seems pretty, hopefully that's just review for you. The sine of 35, 200 sine of 35 turns out to be 115 meters per second, and 200 cosine of 35 turns out to be 164 meters per second. So this is my y, and this is my x. These are the x and y components, which means this projectile is going up, just up at 115 meters per second because of the angle and the speed it's shot at, and it's going forward at 164 meters per second. So, the next problem it asks us is to find the time that's in the air. Well, I know that that's a vertical component. So, don't know what just happened there. Let's backtrack here a little bit. Here we go. Um, we know that the vertical velocity is 115. So my initial velocity in the y direction is equal to 115 meters per second. As it goes up, at some point right up here at the highest point, it stops. So its VF is going to be 0 meters per second. I know that gravity is pulling on it, which is negative 9.8 meters per second squared, and I know that time is what I'm trying to find. So we'll put t in for time. Well, I'm going to use my easiest equation. VF equals VI plus GT in this case. VF is 0. VI is 115 meters per second plus negative 9.8 t. T turns out to be 11.7 seconds. So that's how long it's in the air. So now we found out several things here in our last couple slides. Well, what's the next thing we could do with this projectile motion? How high will it go? Well, I know its speed is 115 meters per second. I know that its final speed is going to be 0 meters per second. That's when it's at its highest point. And I know that time is 11.7 meters per second. Well, I need to find something that gives me a displacement, something that gives me YF. I also know that YI is 0. So in this case, I'm going to simply use my YF equals equation. YF equals YI plus VIT plus 1/2 GT squared. YF, well, I'm going to put, this is 0, that goes away. VI is 115, T is 11.7, and then I'm going to get negative 4.9 times 11.7 squared. What I get here then is the final height is 675 meters is how high it's going to end up being. Well, we've discussed all of its, we found its x component, we found its y component, we found the time. We've also found how high it can go. The last question here is how far is it going to go? Well, this one becomes very easy. All right, we know this is the easiest out of all of them. The time is 11.7 seconds. That's how long it takes for it to go up to its highest point. How long then is it going to take for it to go back down? Well, if it took 11.7 to go up, it's going to take 11.7 seconds to go down. So this time we have to multiply by 2. And time turns out to be 23.4 seconds. If you remember back to our very first slide, we said that its x component, the speed in the x direction, was 164 meters per second. The nice thing about this is its initial velocity is 164 meters per second. In the x direction, its velocity isn't going to change. So if I want to find the distance, it becomes a very quick equation. I can go xf equals xi plus vit plus 1/2 at squared. Xi, we can say that's 0. There is no acceleration in the x direction. So this turns out to simply be 164 meters per second times 23.4. So what does that final distance turn out to be? 3,838 meters. Now, for those of you who are trying to do really well on the test, I hope this has helped you. Review projectile motion. If you want to go back and try something on your own, go back to the original problem here and rework it, changing this from 200 and make that 100. From 35, change it and make that a 55 or some different component. And then go through here and answer the exact same questions with that information in mind. All right. Hey, I hope that helps you to a certain extent. And when I see you, we'll be working on this test. I'll see you on the flip side.